Hello and good evening, dear students. Hope you are all doing well. I'm Dr. Shiraz, teaching electronics course to UTEL University students in this current semester. Uh, I have sent several emails and reminders, and most of the students are doing well, except one student. And I have sent her the email individually as well to please show up and positively complete your activities and assign tasks within due time so that you can be getting good grades. And I also expect that you people go through these recordings and try to learn as much as possible in this course. I am always available for you people. If you have any queries, any questions, you can ask me via your internal email, via your messenger, uh, whatever suits you, or in forum, you can ask the questions as well. And I will be always available for you. So now let's start with our new topic. And for this, I am sharing the screen now to you. So our topic for today is resistors. We have been going through the resistors in previous lectures as well, but we will be studying this topic in much more detail in today's class. So first of all, what do we understand by the word resistors? The resistor word is actually inspired by the word resistance. And resistance means when we are offering hindrance in the flow of something. As we are dealing with the electrical circuits, so resistance is particularly being offered to the flow of electrons or the electric current. And the component which creates this resistance or hurdle is actually known as the resistor. The resistor is a passive electronic component. The terms passive and active are distinguished because they must or must not be fed with an energy source to perform their function. Resistors limit the flow of electrons, divide the voltage, and sometimes generate heat by opposing the flow of currents. Now, this thing is very important. What are the three main functions which the resistors perform? So, they limit the flow of electrons, they divide the voltage, and sometimes they generate heat if they are opposing the flow of the currents. Broadly speaking, we can categorize resistors into two types: fixed resistors and variable resistors. The fixed ones can be found in a great variety of values and sizes, and the size is directly related to the heat which they can absorb. A larger resistor maintains its operation when the current flow is very high. The most common resistor is made from a carbon combination. The ratio of carbon to insulation determines the value of the resistance. Again, this thing is very important to learn and to understand that why the resistors are available in variety of sizes. So the main thing is the size is directly related to the heat they can absorb. So if at some point I want small heat, so I will need a smaller resistor. But where I need bigger absorption, so larger resistor is required. A larger resistor maintains its operation when the current flow is very high. So if the current flow is high, then we need a larger resistor. Similarly, vice versa, if the current flow is less, obviously I need a smaller resistor. The most common resistor is made from a carbon combination. The ratio of carbon to insulation determines the value of resistance. Currently, there are very physically small size resistors in the market, and they are printed circuits for surface mount technology. Tolerance is an intrinsic characteristic of resistors and indicates the variability of their value. Some typical values are 5% and 10%. Some resistors are made of wound wires. This type of resistor does not deal with high frequencies as they generate a lot of noise. So the thing here to understand is what is meant by tolerance. Tolerance is particularly a characteristic of the resistors, and it is an intrinsic characteristic of the resistor. What this indicate? It indicates the variability of their value. So, for example, I say a resistor has a value of 80,000. So if, for example, it is 80,000, so there will be some variability of plus minus something. It may not be exact 80,000. It may be some value above or some value below. And this thing is indicated by some color combination, and which is for representing the tolerance. So now there are two typical values, and those typical values are the 5% and the 10%. Similarly, as resistors are made up of several different types, there are some resistors which are available in the market, which are designed with the help of wound wires. Now, this type of resistor, which is made with the help of wound wire, they does not deal with high frequencies because they generate a lot of noise. Coming to an important topic regarding the resistors is color band code resistors. So first of all, we should understand what do you mean by color band code resistance. Um, Actually, the resistors which are available in the market, if we buy or see it, there will be certain lines on the resistor. These lines have certain indications, and these lines are of different colors for different indications. If I hold the resistor in my hand and I start reading it, so there will be two sides of the resistor. On one side, the line will be very, very near to the hand. So that will be the first line. This is known as the band closest to the shore. This will be the first digit. Then the second band is the second digit. The third band indicates the number of zeros after the second digit. So if, for example, the first digit is 5, the second digit is 3, and the third digit is 4. So this will become 53 multiplied by 10 raised to the power 4. So the third band indicates the number of zeros after the second digit. Then we have the fourth line. The fourth line indicates the tolerance. So in mostly the resistors are of 4 bands, but sometimes there are 5 band resistors as well. So currently I'm talking about the 4 band resistors. Let's take an example. A resistor with colors orange, orange, brown, gold. Now, the first line is orange. How will I remember the code of orange? So this is a color coding table. And if I start with the color, its first one is black, brown, red, orange, yellow, green, blue, purple, gray, and white. So these are the 10 colors. The digits assigned are 0, 1, 2. This 2 is misprinted. This 2 is actually on the red. And going through 0 to 9, it is white. Now, How do I remember? Start with B. B, B, Roy. B is for black, B is for brown, red, R, orange, O, Y, yellow. B, B, Roy. G, B, P, G, W. So that's how we remember as well. B, B, Roy, G, B, P, G, W. So if you remember this spell, it will be easy for you to understand B, B, Roy, G, B, P, G, W. So as in the example, the first color is orange. So it means that the first digit is 3. Then again orange. So it is 33. Then I have the brown. So brown has a code of 1. So it means 10 raised to the power 0, 10 raised to the power 1. So it makes 10. So 330 into 10 makes 330 ohms. Then I have a gold line. These two are the tolerances. Gold is 5% and silver is 10%. So it means that it is 5%. So let's take a numerical question over here as an open class quiz. And I want you people to tell me the code. So this is your first open class question for today. That what is the resistance of a resistor if the 4 colored lines are in this sequence? First one is purple, then blue, then green, and then silver. Please take out some time and do answer this open class question. Now, if for example, the resistor has 5 lines instead of 4. Now, till now, we are aware with the first line, we are aware with the second line, which are the 2 digits. We are aware with the third line, which is actually 10 to the power. The fourth line is actually the tolerance. Now, if the resistor has 5 lines, the fifth band represents the reliability in the percentage of failures per 1000 hours. Now, this is table 2, which actually indicates the fifth line color. This B is again misprinted over here. This is should be like here. It's brown, red, orange, and yellow. Now, if colors are like this, the brown color means it is 1% of failure during 1000 hours of operation. Red is 0.1%, orange is 0.01%, and yellow is 0.001%. So now I will give you another open class question. So in that, we will be considering an example for 5 colors. So question number 2. So this is your open class question number 2. Now, if there are 5 lines, Brown, brown, yellow, golden, and brown. There are many browns, so please be specific to follow the sequence and remember the color coding schemes. Uh, don't be fast. Don't go so fast. Be patient and give me the answers correctly. So, coming back, there is another example for precision resistors. The third band is the third digit. The fourth band is the number of zeros or multiplier, and the fifth one is the tolerance. So these are another type of resistors which are precision resistors. In precision resistors, there are also 5 digits. First one, first value, second one, second value, third one, third value. It is not number of zeros. But now in this case, the fourth one is the number of zeros, which is the multiplier. And the fifth is the tolerance. In these resistors, if the fourth band is gold, it must be multiplied by 0.1. And if it is silver, it must be multiplied by 0.01. The tolerances for this type of resistor are also different. The red is plus minus 2%, brown is plus minus 1%, green is plus minus 0.5%, and blue is plus minus 0.25%. And finally, violet is plus minus 0.1%. Now, violet or purple is the same. So somewhere in the books, you will find the word of purple, and in some books, you will find the word of violet, but it is the same. Both are the same. Some resistors are coded by numerical labeling. In this case, the first and second numbers are digits. The third is the number of zeros or the multiplier. There are also resistors coded in the alphanumeric style. The letter always indicates the decimal point and the multiplier. For example, 22R is 22 ohms. 2M2 means 2.2 mega ohms. 22K is 220 kilo ohms, and so on like this. Now, again, I want to give you a question on precision resistors, and please go through this so that you can give the correct answer, and I want the answer with tolerance as well. So in the numerical, it will be specified for precision resistors, right? Okay. Okay. So dear all, the third question for today is for a precision resistor, find the value of the resistance if the color schemes available on the resistor are yellow, violet, red, silver, and green. So these are the 3 open class questions for today, and I am eagerly waiting that you spare your time and give answers to these questions. Let's continue. So till now, we were talking about the fixed resistors. But as I have told you earlier in my lecture, that there are 2 types of resistors, fixed resistors and variable resistors. So till now we have been discussing all the fixed resistors. So now coming to the variable resistors. So as the name indicates, these resistors have the option of varying the resistance value. These types of resistors are what we find in many of the volume controls in everyday electronic devices. The value of these are actually in rotatory form. So by rotation, you can increase or decrease their value. And for example, if they are connected with a volume or color combination, so the variation can change their values. The value of variable resistors can be changed manually or automatically, as we normally do in the case of volume through remote control. So if I am pressing the volume button up or down, I am actually varying the resistance of that device. The use of typical variable resistors are voltage division or potentiometer and controlling the flow of electric currents or rheostat. Variable resistors can be mechanical or electronic in nature. An electronic resistor uses a specific purpose IC or chip or integrated circuit as we call them to perform this function. Also, variable resistors again can be classified into two types. They are linear and they are non-linear. In linear variable resistors, the value of the resistance is directly proportional to the movement. For example, if you move the mechanism halfway, the value of the variable resistance is half. And if you move it quarter, the value will be quarter. In non-linear variable resistors, the value of the resistance is not directly proportional to the mechanical movement. For example, if you move the mechanism a quarter of the total turn, the resistance value is half. Other examples of variable resistors are temperature and light intensity sensors. The names they receive are thermistor or thermometer resistor and photoconductive cell or photoresistance or photoresistance. Both vary the value of their resistance depending on the value of the physical phenomena, and most important, they are sensitive to the variation of temperature and light intensity. So this all we were discussing regarding the resistances. So to sum up, first of all, what is a resistance? Number two, what are the different types of resistors? Number three, how do we understand the color coding scheme and how we give the answer of a resistor while holding it in hand, that what is its resistance. Then we have seen the fixed type resistors, and then we have seen the variable type resistors. So um, if you find any difficulty, any question, please don't be hesitant to ask me. And I have sent you certain emails regarding your activities as well as assignments. Please go through them and do attempt the quiz which are available, and do ask any questions at any stage in the forum, through email or through your internal messenger. So I will be more than happy to answer to your queries. I hope you will be satisfied with your lecture. And one last question I want to put for as an open quiz today as well. That will be your actually fourth question for the day. So, give names of three variable resistors available in the world of electronics. this you have to search uh, on internet for this. This will be an additional type of question other from your learning resources, but it is important for you people to know by internet open sources what the current electronics is moving towards. So spare this time to give this question as well. So thank you very much for today, and we will meet in the next class next Monday. Hoping to see you all soon. So thank you very much. So kind of you.